Today we'll explore why upgrading to an NVMe SSD is one of the most impactful ways to breathe new life into an old PC, and why it's especially important for CAD professionals. Mass storage in PCs has historically been achieved with hard disk drives. Mechanical hard drives make use of spinning plates to store data, and they are quite slow at around 150 to 170 megabytes per second. This is a 3.5-inch HDD, which is commonly found in desktop PCs, and this is a smaller 2.5-inch HDD, which is more commonly found in laptops. This may be a lot smaller than this one, but functionally they are identical. Unlike mechanical hard drives, solid-state drives or SSDs involve no moving parts. Instead, these make use of flash memory chips to store data. Here you can see the internals of a 2.5-inch SSD with all the flash memory chips exposed. Older SSDs like these two are limited by the SATA interface, which has maximum speeds of around 550 megabytes per second. NVMe, which stands for Non-Volatile Memory Expressed, was designed to overcome the limitations of SATA. These drives connect directly to the CPU via the PCI Express bus, which connects the CPU to other high-speed components like your graphics card. With the SATA bottleneck removed, PCIe SSDs can sustain much higher speeds. This is a PCIe 4.0 SSD, and this is a PCIe 5.0 SSD. This one can sustain speeds of over 7,000 megabytes per second, while this one reaches over 15,000 megabytes per second. For CAD users, however, peak speed is not the only consideration. How quickly the storage medium can respond to a request for new data is also critical. With mechanical hard drives, this was up to 10 milliseconds. On SATA SSDs, this was down to 0.2 milliseconds, and PCIe SSDs could be below 0.1 milliseconds. In practice, this means that opening assemblies, rebuilding models, searching project folders, and saving large files happens much more quickly. A feature that's often overlooked is a drive's DRAM cache, which is something that is not present on budget SSD offerings. This is a small amount of high-speed memory that's built into more premium NVMe SSDs. A DRAM cache keeps a record of where files are located on the drive, and this allows the controller to find data much more quickly. Without a DRAM cache, the SSD needs to work much harder to find files, and this can reduce performance during sustained workloads or while handling many small files. If you work with CAD models and point clouds, you'll notice the largest difference on large projects and complex assemblies. For typical office tasks, the difference can be small, but professional CAD workflows involve constant reading and writing of project files, temporary data, and application caches. A DRAM-equipped SSD usually delivers more consistent performance, especially during long file transfers, rendering and simulation workloads, and when the drive begins to fill up. To sum up, an NVMe SSD is one of the most valuable upgrades you can make to a professional workstation. Of course, storage is only one part of workstation performance. An NVMe SSD won't compensate for insufficient RAM or an outdated CPU. Modena Computers specializes in designing CAD workstations tailored to your exact requirements. That way you can focus on what you do best. If you need a system built, please do get in touch. Thanks.